Okay, good morning, guys. This is the continuation of chapter 6, structural analysis in statics. So, in the first part, we talked about the method of joints. Basically, in the following video, we'll start a new method, which is the method of sections. But before doing this, let's go over the zero force members and let's take the cases where I can predict directly that this is a zero force member. Basically, if I know that this member has a zero force, I can remove it from the truss and thus I can simplify my truss and simplify my calculation. Let's take the example of joint A here. So you can see, guys, that at joint A, I have two members, FA and BA, or AF and AB, it is the same. So as you can see, at a joint A, I have two members that are not collinear. So if they are not collinear, I can directly say that these two members are zero force members. Why? Because in fact, if I take this joint A, and then I draw the forces in the members. So assume, for example, that I will take the force out from the joint. So this is my assumption, and then I can check for my direction. So assume that this is F A E and this is F A B. Since they are not collinear, basically they are perpendicular in this case. And if I want to do sum of fx is equal to 0, because in fact, as you know, guys, the equations of the truss are two equations for each joint, sum of fx and sum of fy is equal to 0. So if I do sum of fx is equal to 0, this will give me that FAB should be equal to what? To 0. So which means that the member AB has zero force, so it is a zero force member here. This member here is has a zero force, so it is a zero force member. And if I apply also sum of Fy is equal to 0, then also, guys, I will get that FAE is equal to 0, because in fact it is the only force in y direction, which means that also this member has a zero force, which means that it is a zero force member. Now this, guys, only the case where I have at this joint two non-collinear forces. And pay attention, guys, if I have another external force, like this case, for example, at a joint A, this will no longer be correct, because if I have another external force at a joint A, then I should add here the projection of this force on X, and I should add here the projection of this force on Y, and then this means that I cannot say that these two members are zero force members. Now here, guys, since at a joint A I don't have any external force, I can directly say that the force in AF is equal to the force in AB is equal to 0, which means the members AF and AB are zero force members, so I can remove them from my truss, as you can see here. Now, the other joint that is also could be removed is the joint D, because in fact at D I have two members, DE and DC, and they are not collinear. Even if they are not perpendicular, they will also be zero force members. Why, guys? Let's know why. Okay, guys, so this is the case of joint D subjected to two forces from the member DE and the member DC. These two members are not collinear, but they are not perpendicular. I will prove now that even if they are not perpendicular, if I don't have any external force and my members are not collinear, I can directly say that these two members are zero force members. How? How? In fact, I know that sum of fx is equal to 0 and sum of fy is equal to 0 are also, these two equations are also valid even if I rotate my reference, or if I rotate my two axes x prime and y prime, which means, guys, if I take x prime parallel to DC, then y prime, which is perpendicular to x prime, will be perpendicular to DC. And if I do sum of fy prime now is equal to 0, what should I have? I will only have the projection of the force dE on y prime, because in fact DC is perpendicular to y prime. So it is the projection of dE on y prime. Okay, so the projection of dE on y prime is equal to 0 means that dE itself is equal to 0, because in fact if I have that the projection on one axis is equal to 0, this means that this force is either perpendicular to this axis, which is not our case, or it is equal to 0. So dE will be equal to 0, and if dE is equal to 0 and then I take sum of fx prime is equal to 0, then this means that fdc will be equal to 0, because in fact dE is 0, so its projection on x prime is equal to 0. So this means, guys, that even if they are not perpendicular, whenever I have two forces that are not collinear and that there is no external force on this joint, then this means that these two forces are equal to 0, or the members of these two forces, or the members that are holding these two internal forces, are zero force members. So let's summarize this here. So if I have a joint, if there is a joint subjected to two forces without any external force, and these two forces are non-collinear, they can be perpendicular or not, then these two forces are equal to 0 and the members are called zero force member. Now the second particular case of a zero force member is in fact for a joint that is subjected to three forces. Two of them are collinear, then the third one will be equal to 0, and the same proof goes here, guys. So let's take the joint D. I have two collinear forces, DE and DC, and I have another force which is DA, could be perpendicular and could not be perpendicular, okay? So it doesn't matter, okay? So here, guys, DA will be equal to 0, not DE and DC. Only DA that is not collinear with these forces, this force should be equal to 0 to achieve equilibrium. And then, guys, if I take joint C, also I have a CD and CB that are collinear, and then CA will be equal to 0. And don't forget, guys, that this case is also valid if I don't have any external force on this joint, and basically the proof is the same, because in fact, let's take joint C, which is more general because I don't have a perpendicular member here. I have any member doing an angle of theta, which means any member that is not collinear with the other two members. So in this case, guys, if I take this as my x, okay, DB as my x, then the perpendicular line will be my y. And then if I do sum of f on y, or y prime, then CA will be equal, the force in CA will be equal to 0. Okay, so let's also summarize this. This is a very important case. So if there is a joint subjected to three forces without any external force, or only to 3 forces. One of them could be external basically, and two of them are collinear, then the third force basically should be equal to 0. And then guys, I can remove here joint D and joint C, because in fact this member DA and CA are equal to 0, so I can get this simplified truss. Thank you.